This is an example of one of these perfectly inelastic collisions, and I'm going to show you how to calculate the change in kinetic energy. Because if you remember, when it's perfectly inelastic, pi, some energy is lost, so energy not conserved. Change, so there's a change in kinetic energy from what you started with to what you end up with. So in these problems, the idea is to calculate the velocity final or the unknowns first. So use the perfectly PIE inelastic equation, solve for the unknown, then use the information you obtained by finding that unknown to then solve for the change in KE, or kinetic energy. So I'll show you that right now. So the first part is perfectly inelastic, and you can see that. So two clay balls collide head-on in a perfectly inelastic collision. The first ball has a mass of this 0.5 kilograms and has an initial velocity of this. The second ball has a mass of this 0.250 and an initial velocity of 3 meters per second to the left. And what is the decrease in kinetic energy during the collision? So it tells you, kind of got to assume it's a perfectly inelastic. They're not going to bounce off, but they're actually going to stick together because they are clay, so they're going to stick together. So we use the equation. We'll put this down first. So mass 1, velocity 1, that's going to be 0.5. I'm not going to put all the numbers in, the zeros in, and it has a velocity of 4 meters per second. Second one, mass 2, and that's going to give us 0.25. Make that little point there bigger. And then the velocity 2 is equal to 3 meters per second. So the lighter one's going a little faster, but in the end, when they hit each other, they're going to stick together and move one direction or the other. So what we have to remember, though, is they're moving in opposite direction. This is right, this is left. So we're going to make this one a negative, because they're not really going to keep the frame of reference correct. Otherwise, we get the wrong answer. So let me plug this in, and the equation is mv1 initial. It's a little bit, I'm not putting the 1 in for this one. Guess I will. Plus m2, go back on that one more time. M2 V2 initial, and that's going to equal two masses combined, M1 plus M2, and then velocity final, because they're now one mass. They have one velocity. So let me calculate. So we got 0.5. I'll worry about significant figures when I'm done. Velocity is 4, right? Then we're going to add 0.25. And here's where it really matters. The velocity is -3. Let's go in the other direction. Okay, and then that's going to equal the 0.5 plus the 0.25. You don't really need those brackets there, but I put them there, so just leave them, times velocity. And that's what we're going to solve. So we do this, we're going to end up with 2 plus 0.25 times 3. It's going to be negative 0.75. And then that equals 0.75 V of F. And then we do this, it's going to give us 1.25 equals 0.75 V of F. Do the math, so we're going to divide by 0.75 here. Both sides. And then we get our answer. Let's get our calculator out. And so we got 1.25 divided by 0.75. It's going to give us 1.66. Looks like we got three significant figures, so 1.67 is going to be our answer. So velocity final is 1.67. meters per second. So that helps us with the next part. So we get this first part done. We now know all the variables. So we just put this new one down here. Velocity final is equal to 1.67. So now we'll get rid of this stuff. We don't need rid of this, so I'll just erase it anyway. Let's make this a little bigger. And then let's see the change in kinetic energy. So we have kinetic energy is, if you remember the equation, you should, kinetic energy is 1/2 mass velocity squared. So now we have two things to start with. We'd have mass velocity squared 1 plus same thing, 1/2 mass velocity squared 2. That's our initial, and then we're going to add that to the mass. That's going to equal, or actually we'll just wait. We'll do this one first. This is kinetic energy initial. And then we just calculate the kinetic energy final, which would be, this 1/2. The two masses, mass 1 plus mass 2 times velocity squared. And that's KE final. We compare them. We would take the final minus the initial to give us a difference or a gain or whatever, but it's going to be a loss. You'll see here in a minute. So if we bring this all down, do some calculations right down here. So we'd have 1/2. The mass is 0.5. And then the velocity is 4 squared. We're going to add that to 1/2, 0.25. And then it's going to be 3 squared. Okay, now here the negative doesn't matter because it's just going to be squared, and then it'll all be a positive because in the reality the direction doesn't matter how much kinetic energy. Just have kinetic energy go in one direction or kinetic energy go in the other. So then if we do the use the calculator here, we solve each one. So 0.5 times 0.5 times 4 times 4 gives us 4, the first one. Then we add, so 4 joules for that one. Then we do the other one, 0.5 times 0.25 times 3 times 3. It's going to give us 1.125. So that's going to give us 5.125 joules. That's initially. That is this one right here. So then we do the other one. They just bring this equation down. We're just going to add the masses. So it's 1/2, and if we just add the masses in our head, 0.5 plus 0.25 is going to be 0.75. And then the velocity is 1.67 squared. we do the math. Go over to our calculator, and we go 0.5, clear that, 0.5 times 0.75 times 1.67 times 1.67 equals 1.0. We'll just round it, 1.046 joules. So those are our two energies we end up with. And then we would just take this 1.04, or almost make it 1.05, and let me erase her a little bit. Hopefully you got those answers. Just write them down if you don't. So we end up with those two things. We'll just erase around them. And what we want here is, so we'll write these in, kinetic energy initial is going to be more, because remember we're going to lose some. It's 5 point, we'll just go to 3 decimal, or 3 significant, 0.13. Kinetic energy final is going to be 1.05. These are each joules. So if we get rid of this, we'll be able to do the calculations real easy. It's going to be a negative number because you're going to lose it. So in the end, you're going to have less. So in the equation is kinetic energy final minus kinetic energy initial equals the change in kinetic energy. So final is 1.05, very nice decimal, minus 5.13, and that gives us 4.08 joules. That's how much you lost. Minus 4.08 joules. So that's the loss of energy. And that's how you do the perfectly inelastic collisions, the change or the loss of kinetic energy. That's how you do them. Let me know if you have any questions. They're a little bit more complicated, but you should know how to do them. If you have to watch this twice, and I'm sure you'll get it. And hope that works for you. Let me know if you need any other problems done.